Shalom to you and welcome. In this video, we're going to look at other methods of proving triangles congruent. We have looked at side, 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 side angle, side, angle, side angle. So we're going to look at HL, which is hypotenuse length theorem, and angle, angle, side theorem, or rather postulate and theorem. So so we're going to use HL and AAS theorem to prove triangles congruent. Those kind of a ritual. So a quick review of different parts of hypotenuse is very crucial. You know when it is leg and when it is hypotenuse. So because it has to be one leg and the hypotenuse for it to work. If you have just the two legs congruent, then it doesn't work. It has to be one hypotenuse. It has to be the hypotenuse and one of the legs that are congruent. Okay. So again, hypotenuse is directly opposite the right angle. The side opposite the right angle is the hypotenuse. Like that. Okay. So the theorem says that if you have one of the legs congruent to one of the legs of the other triangle and the hypotenuse congruent to the hypotenuse of the other triangle, then the two triangles are congruent. So that's HL. So here we have the right angle, the hypotenuse, and then we have the reflexive property of RV are congruent to itself, is congruent to itself. Therefore, these two triangles will be congruent. Likewise in this one. The angle side is when you have two congruent angles in one triangle and its corresponding parts to another triangle, and at least one of the sides congruent. So we have seen angle side angle where that side is inside, is included between the two angles. But this is when that side is not included. So when you have two angles congruent and any one of the sides, that the triangles will be congruent. Okay? So the idea that when the sum of three angles in a triangle is equal to 180. So when you already have two of them congruent, the last one, the third one, must be congruent as well. So, but that alone does not create congruent triangles because they could have the same angle measure and yet not be congruent. So that's why I have to have at least one side that is congruent. So here you see we have two angles, and then we have the reflexive side, which is congruent. So angle side. Okay, which congruence method would you use to prove this one? Now be careful. It's not whenever you see a right triangle then you think it's HL. Again, you have to check to make sure that you know the hypotenuse. You could have a right angle and the stick could be side, 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 or side, or angle, side, angle. So you just have to look. So, but check for HL first. So here we have the right angle and the side opposite it. It's not given, but we know by reflexive property that side will be congruent to itself. And that side is actually the hypotenuse. So hypotenuse is opposite the right angle. So we have the hypotenuse congruent to both, and then we have one of the legs congruent. So this will be HL. How about this one? How could you prove these two triangles? Again, they are right triangles, but is it HL or other things? Okay, again, we know this side is reflexive to itself, but then we have angle. This is the hypotenuse is opposite the right angle, so but we don't know the hypotenuse is not congruent, so it cannot be HL, but it's angle side, angle side, or side angle. They are the same. So angle side will be that. How about this one? I hope you see, again, it's the right angle, but it's not HL because we don't know the hypotenuse. But we have side, angle, side. The angle is inclusive, is included. So it's side, angle, side. You see, we have seen 3 right triangles now. Each one of them is different. So it is not always HL, it could be any. But if you have the hypotenuse and one of the legs, then it will be HL. Let's do a disproof. Okay, we are given that this angle circle O, and whenever we see a circle, we think of radius and radii. All radii are equal. Okay, so we look at this figure here. It's a quadrilateral with 4 sides. So we are given that YO is perpendicular. Okay, this is YO is perpendicular to YX. So we can have a right angle. Let me use a different color. It means we have a right angle right there. And likewise, ZO is perpendicular to. So we have a right angle. So based on this, we can say angle XYO is congruent to angle XZO because right angles are congruent. Okay, right angles are congruent. But we need 2 triangles in order to get, because we want to prove the side, the YX, that these long sides are congruent. So we need 2 triangles. So we can always draw the auxiliary line. We can cut it into here from O to X. So we can draw auxiliary line. So draw segment OX, which will be the auxiliary. So 2 points determine a line. Okay, we need to always write that whenever we draw auxiliary lines. So we have 2 triangles now to work with. So let's try to prove those 2 triangles congruent first. And so we know OY is radius, just like OX. So we can say that OY is congruent to OZ. Radii of a circle are congruent. Okay, so we have side, we have angle. What else do we know? Well, this is a right triangle. Each one of them is a right triangle because of the right angle. Therefore, so this line OY is also reflexive to itself. So we can say OX is congruent to OX by reflexive property. Okay, so therefore we know that this is the right angle and this OX is the hypotenuse because it's opposite the right angle. So we have the right angle and then we have one of the legs. So therefore, triangle XYO is congruent to triangle XZO by HL, hypotenuse leg. And therefore, we can conclude by saying that YX is congruent to ZX by CPCTC. Corresponding parts of congruent triangles are congruent. Okay, this is a fun, again, connecting circle, auxiliary, perpendicular, okay, and with HL. Very nice. Okay, so what would you use to prove these 2 triangles congruent? And check your answer. I hope you can see that we don't have any side here, but this is reflexive, WZ reflexive, so we have angle, angle, side, angle, angle, side. So we have angle, angle, side, or side, angle, angle, whichever one is the same. As long as it's just that it has 2 congruent angles and then 1 non-included side. Let's try this another proof here. Just complete the table. So we are given that Hj, which is this line, is congruent to Ji, which is this long one also. And if you look at those lines, these two triangles, there's the two sliding triangle here, IHG, which is one of them. This is overlapping triangle. So that triangle is a right triangle because we see the sign there. So these are all given. Okay, so GH, we said that GH is congruent to GH, which is this one, is congruent by reflexive. And so the two triangles are congruent because GH is one of the legs, but for both triangles. And then IG and HJ, they are hypotenuse, so it's congruent by HL. So HJ and they are right angles. So this is right angles. They are congruent, they are given. Oh, sorry. So that's kind of given from the picture. And so this is HL. All right, that's done. What would you use to prove these two triangles congruent? So, we have a vertical angles here, so that will be, it will not always be given, but you figure that out. We have angle, side, angle. The side is included in between the two angles. Again, angle, side, angle. So it's angle, side, angle. Next, about this one, again, we have vertical angles here. So we'll mark it. So we have angle. Oh, we're gonna go other round. So we're gonna have side, angle, angle, or angle, side, side. Again, angle, angle, side. So it's angle, angle, side, or side, angle, angle. Okay, hope you get that.